Hi, my name is Gan Tianbei. My student ID is TG22050. I'm a student from UMPSA, Pekan, Pahang. This subject is BTE 4733, Sensor Technology, and my lecturer name is Dr. Muhammad Razali bin Daud. Today, I'm going to explain about soil pollution, capacitive vs resistive sensor. Starting off, let's look at the agenda for today. The first one will be overview of soil pollution. Second one will be impacts on environment and health. Third will be sensor use, capacitive vs resistive. Fourth will be working principles. Fifth will be solutions to mitigate soil pollution. And lastly will be the conclusion for this presentation. First of all, we'll be talking about the overview of soil pollution. So what is soil pollution? Soil pollution refers to contamination of soil by harmful chemicals, heavy metals, industrial waste, pesticides, and improper disposal of solid waste. Common sources come from agricultural activities using fertilizers and pesticides, industrial discharge, mining activities, landfill leakage, and accidental oil spills. Some of the negative impact including polluted soils loses its fertility, reduces agricultural productivity, and becomes a long-term source of environmental contamination because many pollutants remain in soils for years. The chart is from Handbook of Environmental Materials Management. It shows that the sources for soil pollution. 8.2% of the soil pollution come from others, 0.9% come from military, 1.4% come from mining, 2.1% come from transport spills on land, 3.9% come from power plants, 5.4% come from storage, 7.3% come from industrial waste treatment and disposal, 7.3% come from oil industry, 15.2% come from municipal waste treatment and disposal. The largest source of soil pollution is actually 41.4%, which is they come from industrial, production, and commercial services. Let's talk about some impacts on environment and health from soil pollution. The first one is it reduces soil fertility and crop productivity. The second one is damages beneficial soil microorganisms. Third, soil pollution will cause and contaminates groundwater through leaching. The fourth, it causes long-term accumulation of heavy metals in soil. Number 5, it affects plant growth and ecosystem balance. We can look at this picture. This is the quantifiable economic losses due to soil pollution. Some of it include unsafe food, polluted water, loss of biodiversity, loss of workforce and productivity, human diseases, increased uses of agrochemicals, decreased crop yields, and also decreased soil productivity. Moving on to the next one, we will be talking about the sensor use for soil pollution, which is the capacitive vs resistive. Capacitive soil moisture sensors are the one at the left side, while resistive soil moisture sensors are the one at the right side. The table shows the comparison between the feature of capacitive soil moisture sensor and also the resistive soil moisture sensor. The basic working principle for capacitive soil moisture sensor is it uses capacitance to measure changes in soil, while resistive soil moisture sensor measures changes in electrical resistance. The sensing method Capacitive soil moisture sensor uses soil as dielectric between plates, while resistive soil moisture sensor uses two metal probes in soil. The sensitivity to salinity for capacitive soil moisture sensor is low, while for resistive soil moisture sensor is high, where capacitive soil moisture sensor will have less affected by salts, while resistive soil moisture sensor is strongly and highly affected by salts. The corrosion on the sensor for capacitive soil moisture sensor is low and it has no direct metal exposure, while for the resistive soil moisture sensor, the corrosion is very high as metal blocks corrode over time. For the stability, capacitive soil moisture sensor is more stable and is high stability for long-term use, while resistive soil moisture sensor have low stability and the stability drift with time, as it will be going down as time goes by. For the accuracy, capacitive soil moisture sensor is higher and more accurate in long term, while resistive soil moisture sensor have less accuracy over long term. For the maintenance, capacitive soil moisture sensor requires low maintenance, while resistive soil moisture sensor requires high maintenance and it keeps needing replacements. For the cost, capacitive soil moisture sensor will be slightly higher, while resistive soil moisture sensor will be low cost. The typical lifetime for capacitive soil moisture sensor is high and long, while resistive soil moisture sensor will be very short. From this table, we can conclude that capacitive soil moisture sensor is suitable for long-term monitoring, while resistive soil moisture sensor is suitable for short-term, low-cost project or prototyping. Now, we will be looking at the working principle for these two sensors, starting off with capacitive soil sensor. A capacitive soil sensor works based on changes in capacitance between two conductive plates. The soils act as a dielectric medium between the plates. When soil moisture or chemical composition changes, the dielectric constant changes, causing a change in capacitance. This changes is converted into an electrical signal that represents soil condition. Capacitive sensors are less affected by corrosion and salinity, making them suitable for long-term monitoring. You can look at this picture where the copper trace acts as a capacitor and there will be a timer IC at the right hand side. Now I'll be going through the resistive soil sensor. A resistive soil sensor works by measuring the electrical resistance between two metal probes inserted into the soil. When soil moisture or ionic concentration increases, electrical conductivity increases and resistance decreases. Pollutants such as salts and heavy metals increase ion concentration, which significantly affect resistance readings. However, resistive sensors suffer from electrode corrosion and edging, which will be reducing long-term accuracy, which is also from what we discussed previously at the tables. So looking at the pictures, you can see the right electrode, left electrode, and also the non-polarized connector pins at the right hand side. So to prevent soil pollution or to reduce or to mitigate soil pollution, there are several ways. First is proper waste management and controlled uses of fertilizers and pesticides to prevent further contamination. Second is to use soil remediation techniques such as phytoremediation, uses plants to absorb heavy metals from soil. Third is continuous monitoring using capacitive or resistive sensor to allow the early detection of contamination and prevent several damage done to the soil or done to the land. Lastly, is the help from government regulation and public awareness to ensure that sustainable soil management. From today's presentations, we can conclude that soil pollution requires continuous monitoring Sensors are essential for early detection of contamination. Resistive sensors are low cost but less stable, while capacitive sensors are more durable and reliable, especially for long-term projects. Sensor-based monitoring supports sustainable soil management, and it helps protect environment, food safety, and human health. This will be the end of my presentation for today. Thank you very much for listening.